Good day, everyone. I want us to quickly solve this problem. If 100 cm cube of hydrogen diffused through a porous pot in 1.0 seconds, how long will it take the same volume of oxygen to diffuse through the same pot under the same condition? Now, if you want to solve this problem, the first thing you have to understand is that this problem is under the Graham's law of diffusion. It's under Graham's law of diffusion. So if you understand that, then you have to know what are some of the parameters that we have under Graham's law of diffusion. So I'm going to write the formula that we're going to be using, and from there we are going to see how we are going to bring out the parameters from the question. Now, if the Graham's law of diffusion states that at constant temperature and pressure, the rate of diffusion, let's say the rate of diffusion of gas 1 is R1. So the rate of diffusion of gas is inversely proportional to the square root of its relative molecular mass. So what are we trying to say? What we are saying is that the rate of diffusion of gas 1 divided by the rate of diffusion of gas 2 is going to be equals to the square root, we're going to write the square root of, then the molecular mass of gas 2, remember, it is inversely proportional to the square root of its relative molecular mass. So why we have over relative molecular mass of gas 1. Now, what are we trying to say here? I want you to look at this formula critically. The rate of gas 1 divided by the rate of gas 2 is equal to the square root of molecular mass of gas 2 divided by the relative molecular mass of gas 1. I want you to see that R1 over R2 is equal to square root of M2 over M1 and not M1 over M2. Please, I want you to take note of that. So meaning that I'm going to clean this formula. I'm going to clean it because we are going to be writing it later. I just want you to realize that from the question, we need to get the rate of first gas, we need to also get the rate of the second gas, and then we need to get the molecular mass of the second gas and the molecular mass of the first gas. And that is what we are going to substitute into this formula before we finally solve the problem. Now, let's quickly do that. We have been able to see that this R represents the rate of diffusion of the first gas. The second one also represents the rate of diffusion of the second gas. The R1 represents the rate of diffusion of the first gas. The R2 represents the rate of diffusion of the second gas. The M we have here is the relative molecular mass of the second gas, M2, then the relative molecular mass of the first gas, M1. Now, that is what we are going to be getting from the question. Now, let's see how we are going to get this from the question. Now, we are going to get the parameters. So the first thing is, if 100 cm cube of hydrogen. So we know that one of our gases is actually hydrogen. So I'm going to say that the volume of hydrogen is that the volume of hydrogen is actually 100 cm cube, and then diffuse through a porous pot in 1 second. So the time it takes for it to diffuse is actually okay. I'm going to say the time is actually 1 second. I'm going to say 1 second. Now, through a porous pot in 1 second, how long will it take the same volume of oxygen to diffuse? I want you to look at this. How long will it take the same volume of oxygen? So meaning that the volume of oxygen is the same thing as the volume of hydrogen given to us, because the question says the same volume of oxygen. So I'm going to write that the volume of oxygen here, I'm going to use subscript O is equals to 100 cm cube. Why is it the same thing as the volume of hydrogen? Well, the question says the same volume as that of hydrogen. So cm cube. Then what about the time? Well, the question says how long will it take the same volume of oxygen? How long will it take the same volume of oxygen? Meaning that they are not giving us the time for oxygen to diffuse. So we put question mark. So meaning that anywhere we have the time T because we don't have it. Well, the thing is that it is very good when you bring out your parameters like this and then you know what you're going to do. But remember that from the question, from the formula that we have the rate of diffusion and not the volume. And a lot of students make mistake, they substitute directly the volume. No. Now we have the rate of diffusion, so meaning that you're going to find the rate of each gas. Now the rate, anytime we have to do something has to do with rate, it has to do with time. So meaning that I'm going to find the rate of diffusion of hydrogen gas. So I'm going to say rate of hydrogen is going to be the volume of hydrogen divided by the time for it to diffuse. And that's what I'm going to say 100 divided by 1. So and that is going to give me what? Of course, that is going to give me 100. Well, it's still going to give me 100. So that's going to be 100 cm cube per seconds. Now, what about the rate of diffusion of oxygen? Well, the rate of diffusion of oxygen is going to be the volume of oxygen as well. The volume of oxygen divided by the time for oxygen to diffuse. And that is going to give me the same thing, 100 divided by T. Well, why am I not substituting a value for T? Because we don't have the value for T. The question didn't give us the value. So, and then I'm going to have 100 divided by T, then cm cube. We are going to have cm cube per seconds. Well, this is what we are going to have. Now we have the rate of diffusion. What about the molecular mass? Because we have that the parameter in our formula as well. So we have to find the relative molecular mass of hydrogen. So the relative molecular mass of hydrogen, I'm going to say mH. And don't forget that the relative molecular mass of hydrogen is actually 2 grams. Somebody is going to ask the question, how did we get the 2 grams? Of course, you know that hydrogen atom is H, while the hydrogen molecule is actually what? H2. So this is going to give us the molecular mass. So if we find the hydrogen, the atomic mass of hydrogen is 1, then times the 2. And don't forget that this is H2, hydrogen molecule. So we have 1 times 2, and that's going to give us 2 grams because of these 2 that we have as a subscript. And that's how we got the 2 grams. So now, having understood that, then you find the molecular mass of the second gas, which is oxygen. Well, oxygen is actually a diatomic gas as well, like hydrogen. So I'm going to say O2 is actually, that is atomic mass 16 times 2, which is going to give me 32 grams. 32 grams. 32 grams. So, and that is how we are going to get this 32 that we're going to write for oxygen. So the relative molecular mass of oxygen is also going to be 32 grams. Now it's very perfect now, meaning that we have all the parameters to substitute. Very fine, very good. Now let us try to substitute all these parameters into our formula. Now, look at this, everyone. Well, what is our formula? Is actually R of the relative, the rate of diffusion of what? Of hydrogen. Remember, you can start with the rate of diffusion of any gas. So rate of diffusion of hydrogen divided by the rate of diffusion of oxygen, then it's going to be equals to the square root. Remember, we have this now as part of our formula. The square root of the molecular mass of our oxygen is going to come first, and then divided by the molecular mass of hydrogen. And well, this is Very simple. Since we are just going to substitute our values, remember that of hydrogen is 100, so I'm going to put 100. Then divided by, well, I would love to use this type of division, and I have my reason. I don't want this thing to be too long. So divided by the rate of division of oxygen, which is actually 100, divided by time. Because we are looking for the time for the same volume of oxygen to diffuse, and that is the time that is in our formula. So square root of is going to be equal to square root of, then the molecular mass of oxygen is actually what? Is actually 32. So I'm going to say 32 divided by, then the molecular mass of hydrogen is actually what? Is actually 2. Remember, we are just trying to substitute all these values. All the values that we have here are what we are trying to substitute here. So the values that we have here is what we are trying to substitute here, and that is what we have substituted. So remember, remaining for us to solve the problem. So now I'm going to do this. That is going to give me 100. Well, remember the law of fraction. You're going to turn the division to this division, you're going to turn it to multiplication. I want you to do that. You are going to interchange the fraction. That's going to be what? T over 100. T over 100. And remember, this 100 is down. Well, it's going to cancel this 100 here. So I'm going to be left with T. So at the right-hand side, I'm going to be left with square root of. Then if you go back to this point here, you know the 2 is going to divide, go in 32 16 times. So I'm going to say 2 here 1, 2 in 32 is actually going to give me 16. So I'm going to write square root of 16 here now. So that is square root of 16. Well, T is actually equals to the square root of 16. So meaning that T is equals to, the square root of 16 is actually 4. So it's going to be 4 and 4.0 seconds. So meaning that it's going to take, why it takes 1 second for 100 cm cube of what? Of hydrogen to diffuse. It's going to take oxygen 4.0 seconds to for the same volume to diffuse. And that is the solution to the problem. Thank you.